Hello everyone, this is Roger Brogan, and today we're going to see how to turn our regular Pocket node into a Validator node. In some prior videos, we demonstrated how to get a Pocket node up and running and syncing with the blockchain. I have SSH'd into this node right here that is up and running, and I'm looking at the log output here to make sure that everything is looking fine. So this is nice and synced with our testnet. We're going to do this on testnet first and then switch over to the mainnet after we know that everything is working okay. And a good command to just check things out is to curl to the local host on 26657/status. We'll take a peek at a few things in the response. Number one, we can verify that we are on our network testnet, so we are in fact on the testnet. We can also verify the address that we have for the validator, which we'll see how to actually set that up in the beginning here. And we can see that catching up is false, so that means we are actually synced to block height 6044 at the time of this recording. So the very first thing that we want to do is to create an account. When you first start with this node, there's not going to be any accounts created, and an account is essentially going to be cryptographic private and public key pair. And that's, the public part of that is going to be used as your identity for the node, essentially like your wallet or your account. So we're going to go ahead and create one. It's asking you for a passphrase here, so use one that's nice and long but easy to remember. And voila, we've now generated an account. So we can take a look at the accounts that we have available. You can have multiple ones. For example, I just created another one there. So let's take a look at the ones that we have available now. And we now have three. I had a prior one from a prior example. So we're going to continue with the last one that I created here. So we're going to be using this as our validator account. And if you're going to be changing configuration on your node, I think it's a good idea to go over to the other command that I started this with, and I'm going to do a Control-C, and I'm going to stop the daemon there, and then I'm going to hop back over to my other command window here, and we're going to change the validator address here. So if we look at Pocket accounts and we get validator, it's going to tell us what the current validator address is, which this is one that I had been using in some prior testing that I've been doing. So for this one, we're going to pretend like we're setting this up fresh. So what we're going to do is use a similar command, but we're going to set the validator. And we're going to set the validator using this public address. So I'm going to just use the screen here to just go ahead and copy and paste that exact address. And you have to use your passphrase to unlock the private key portion of this. And assuming that is, you type all that in correctly, we can see that our validator is now set to this address. So we're going to use this address as we continue on here, okay? Now, we're going to go back over to our other window, and we're going to do the Pocket start command and allow this to get syncing back with the testnet. The next thing that we need to do is we need to create a chains.json file. Now, the chains.json file specifies the other chains that you're going to be able to support. And for this testing, I have set up a Rinkeby node, which is an Ethernet testnet. And if we go over and take a look at the supported networks here, we can see that the networks that Pocket support on their testnet is a nice long list here. And if we go down to the Ethernet section, we can see that for Ethernet testnets, they do in fact support Rinkeby. And the chain ID, which is the last column here, 0022, that's important when we set up our chains JSON. Okay. You also need to have access to either an Ethereum node. I happen to be running an Ethereum Rinkeby node that I have access to, but you could use a gateway like Infura, but ideally it's something that you're running yourself. All right, so this guy is running again. We can do a nice quick check to make sure that we're synced back up, and that is correct. We could also validate that our validator address is different here. And so we're going to go ahead and generate our chains JSON. And we can use this command right here. That didn't get copied over here correctly. There we go. Now the first thing is the network. It says enter the ID of the network identifier. And if we look at all of these, we've got a net ID, a network, and a chains ID. Since we're generating the chains.json, it's the chains ID that we're interested in, which for Rinkeby was 0022. And then now is the URL, the network identifier. Now I told you I had a node running, and I do. And just to verify that it's up and running in the correct address, I will pull over a little utility I use here called Postman. And we're going to take a look at the setup here. And this is the actual address that it's going to use. This is this very long string dynamic DNS DAP node and 32770 port. So I'm just going to go ahead and grab that out of here. And we'll copy that. And it's at HTTP. Let me go ahead and paste that in there. And if you want to add additional chains, all of these other chains are supported in the testnet. You could add additional ones if you like, but we're just going to leave it with the one. Then it tells you a little bit of output there. You can also take a look at what that generated for you, because this will actually live here in the Pocket config directory as the chains.json file. And as we guessed correctly, or if we entered the data correctly, we've got the ID correct, the URL correct. So that looks good. So we'll just exit out of there. And if we want to double check the command that I'm going to send over it, we have a simple Ethernet get balance command. And this is a wallet that I have set up with some Ethernet in it. And if we send this over there, we're going to see that we do get the balance for that account. And just to prove that it's actually working, I'll change this to say an account that doesn't exist that I know of. We'll send that over, and we can see that we do in fact get a 0. When I use my correct Ethernet address, I get the balance that I have. Okay, so that's working correctly. That's good. And another thing that we can do to make sure that our node is configured correctly is to run the node in a simulate relay node. Okay, and we'll go ahead and do that right now, and then we'll come back to funding the node here. What you need to do is shut it down with a Control-C here. And then when you run it, you add an additional flag here called simulate relay. And when you run it in simulate relay, it allows you to send a curl command that is going to essentially act like a relay, which means that if it got this command targeted at Rinkeby net, it would forward that over to Rinkeby and execute the command and get the results back. So in other words, what we should get if we send it the same command is we should get the same result, but this time coming back from our node. So let's go ahead and do that. I've got the command that we want to use to execute that. And I'll go over this command. It's kind of a long one here. Okay, so I'll just go back to the beginning of this command. We'll go over each piece. Now, first off, we're just going to curl a post request. And the data that we're going to send up in the post is JSON. So we have to send in the chain URL, which is the same URL that I used for the Rinkeby test node. And then we specify the payload, which has another data section here, which is the JSON RPC version 2. This is the command eth_get_balance. The parameter is the actual Ethernet wallet address that I used in the other one, chain ID 1 and method post. And then the path is out to our local host, port 8082/v1/client/sim. And if we execute this, we should get the result back with the same balance here that we did when we executed it directly against the node. And lo and behold, we get the same result as 0 or the 0x1043516, etc., etc. Okay, so what that means is that our Pocket node can successfully access the other chain. So that means all of the networking and the ports and the configuration, all of that, and the network connectivity is set up correctly. Okay, so now we need to fund the validator node. If we become a validator node and we start doing work on the network and want to get compensated for that, we have to become a validator node. So the way that we have to do that is we have to stake some Pocket. So we need to go get some Pocket. And the way that we do that is via this testnet faucet over here. Okay, so what I did is I just grabbed our public address, and you've got to post the public address in there and push the get testnet Pocket button here. And that was an old page, I guess. That's an invalid success. So or invalid result, not a success. What we want to see is something like this. Okay, so that's the actual transaction ID, which I'm going to copy for use later. We can take a look at this one. And so that granted 20,000 Pocket from the testnet over to our address. And then that means that we can go ahead and execute now the staking transaction to stake our node. Now, let's look at some commands that we use to understand the status of our node, and we'll look at the differences between when it's staked and when it's not staked. If we take a look at our actual node here, and I'm going to copy this address here so that we can reuse it in some of our commands here. One of the ways we can take a look at this is we can just do Pocket query the balance, and we can put in our address. Right now it still says 0 because these blocks happen every 15 minutes, and it is not actually caught up with the fact that we do have 20,000 Pocket coming our way. We've got some other ways we can take a look at this as well. Let's take a look specifically at querying the node here, and we'll query the node. Okay, and it's telling us the validator is not found. Okay, so let's take a look at the status here. We can see that we are catching up. This is our validator, but right now we're not a valid validator on the network. Okay, so in order to become a valid validator on the network, we need to actually create our staking transaction. Okay. Now, before we forget, we don't want to allow this to continue to run with simulate relay. So let's go ahead and do a Control-C and start this up again with just the command Pocket start so that we're not simulating a relay here. And then let's take a look at our status again here. Make sure that we're still caught up. And let's query our node again. It still doesn't consider us to be a valid validator on the network. All right, so how do we become a valid validator? Well, what we're going to do is we're going to need to stake some Pocket here. So the command to do that is going to be Pocket. We'll set up our stake command. This is the address that's doing the funding. And the rest of this, I'm going to copy the rest of this command, but we're going to go over all the different pieces of this here. Okay. Had an extra carriage return in there that it didn't like. So let me go ahead and just type this out normally here. All right, so what we have here is the Pocket stake command, the address that we're coming from, what we're staking. We're going to be staking 15,000 and then 1, 2, 3, 4, 5, 6 zeros at the end of that because The denomination here is micro pocket, so we need to tack on 6 zeros for that. This is the chain that we're going to be validating against. So this is matching up to our chains.json. This is the Rinkeby testnet. And this is my DNS name and HTTPS for my Pocket node. Notice at port 8081. The testnet is the net that we're going to send this transaction to for staking. And our fee is going to be a 10,000 micro pocket. I've got, what do I have in there? Looks like, yeah, 10,000 micro pocket. Go ahead and execute this command. And I am missing pocket nodes. It's a nodes command here. So pocket node stake. It's asking you for your passphrase because it's going to need to sign this with the private key. And this is what it looks like when it is not successful. Signature verification failed. The blocks happen every 15 minutes in Pocket. So let's see where we're at here. We're at block 6045. All right. So we're going to have to wait a little bit of time here. And we can wait until block 6046 and give this transaction another try. Or we can just keep trying it. We don't know exactly when the next block is ready exactly, but it's roughly about every 15 minutes. So we're going to hang out and wait, and we're going to try the staking transaction again. Okay, let's give this a shot again here. And success. This is what we wanted to see. Let's take a look at the output here. Obviously, this was an action to stake a validator. And success is true. So this is what we wanted. This is also the transaction hash, which we could keep that if we want. We could examine that transaction as well. All right, so what are some other things that we can do to make sure that our validator is working correctly? Let's take a look at our query height. We are on the next block. Let's take a look at our actual node here. So it looks like we just got our validator transaction in. So it looks like we're going to have to be waiting until the next block to get some status on that. But let's use our other command for status, just the local host status. We are still synced, still on the test net. This is the correct validator. So we're going to give it until the next block height here, and we're going to make sure that everything is actually running as it should here when we take a look at our node status. We should be able to take a look at our balance here. Let's look at a balance for our address here. Okay, and we can see that it is now registering the 20,000 pocket that we originally got from the faucet here. So it hasn't actually subtracted the 15,000 out plus the fee. So that should get taken out on the next block here. In the meantime, since we saved that transaction address, let's see if we can get a little information on the transaction here. Command to do that is pocket query. Look for account transaction TXS, and we're going to need that transaction, which we could grab right from up here, as well as where I'd saved it before. Let's use that. Let's try our account in this one. Okay, so none of the transactions are coming up yet. We're going to have to wait till block 6047, and we'll come back after that block posts. Okay, let's take a look at what this looks like now with the next block here. First, we'll take a look at our balance, and we can see that the balance has been deducted. Okay. Nothing on those transactions, but let's look at the status of our node here. Still looks good. Now let's look at the query our node here. Okay, so this is what we were hoping to see to verify that we're actually on the chain here. So this is our address, which is correct. We are on chain 0022. Rinkeby testnet. This is our public key. Our service URL is correct. And this status number 2 here is important. This is the fact that we are in status staking, and we have our stake tokens right there. And there you have it. That is going through setting up our node from just a regular synced node to setting up the validation. We have actually gone through this process here. We've set up the chains, we've created the account, we have funded the node, created the staking transaction, and now we are all set, right? We can see that we are in fact staked. Okay, and that's going to wrap it up for this video. Thanks a lot.